All right, all right, all right. It looks like we are live. Welcome, everybody. I had to shift the time. Let me go ahead and apologize. A lot of y'all are probably used to the 9:45 a.m. starting time, but we had to switch it down to 9 a.m. this particular week just because I have, a client schedule change and I try to accommodate when I can. And so I didn't feel like it would be such a big deal if we maybe started about 45 minutes earlier than normal. It should go back to normal schedule at 9:45 a.m. Next week. But anyway, if you don't get a chance to catch this live, a lot of you guys can watch the replay. So that's always available to you. And just so you know, we have switched over unless we have a problem. If anyone, doesn't like it, I'm going to try to start doing our lives on YouTube versus what we were doing on Facebook, just because of how easily YouTube is accessible. You don't have to have an account with YouTube, right? Like you would have to have a Facebook profile or something like that, or be friends with someone on Facebook. There's a lot more parameters that you have to jump through with Facebook. YouTube, I can simply send a link, text it out to anybody, and you have access to it. So without further ado, let's go ahead and get into this. I only have a few. Let's see. I got a handful of topics, but I got like maybe three main ones I want to hit today. If you start, if you're in my Algebra Made Simple program, we were talking about the concept or introducing the concept of polynomials, right? And how to factor them specifically. Okay, so some of you guys are dealing with that. That is a huge skill set that I feel like you need to hit if you're taking a 10-week course, because not only is it something that you get introduced to about midway through the course, but it's so useful in so many ways. You can find out solutions to polynomial functions. You can predict, how long something's going to be in the air before it lands, for example, with quadratics, and you have to use that skill when it comes to division and some reducing of rational functions. Anyway, it's a very useful skill. You use it over and over, and you can't just overlook it, okay? So when it comes to factoring a polynomial, the number one golden rule, and I'm going to put this in the comments for anybody who might be watching, even if it's not live, you watch it on the replay, it should show up. The number one rule, anytime you're asked to factor, you need to look for a GCF, which obviously, if you've taken my course, if you know it, means greatest common factor. Not every polynomial will have a GCF, but it is your job as a mathematician to look for one. Just like a doctor who shows up, let's say there's a light, unconscious body laying on the ground, right? The first thing the doctor is probably trained to do is check for a pulse, see if they're breathing, look for vital signs, see if they're alive, right? If they're alive, you're going to do a whole bunch of different protocols than if you can determine that the person's dead. You're going to take a different course of action, right? So checking for the GCF is kind of like that. It's like a first it's a protocol that we go through, right? So for example, if you have a simple polynomial, I'm going to do one such as, let's do this one. We're going to do 7x to the second power. This is a quadratic because the degree is 2, and it's a binomial because the degree, the number of terms is 2. We say binomial for 2 terms, quadratic for a degree of 2. So here's what I'm talking about. All right. This is probably like when you're introducing this concept, even if you're taking a typical like full year course, they're going to start with this kind of polynomial and ask you to factor. And so step 1 is look for a GCF, determine whether or not there is one. So what you're going to do is you're going to look between the 2 terms. You got 7x to the second. You got, what is that, 21x. And you say, well, do they have anything in common? My suggestion is to start with the coefficients and then go to the variables. So when you're trying to find the GCF, you're looking between 7 and 21. You're like, well, what's the greatest factor that both 7 and 21 have in common? In other words, what times what gives me 7? What times what gives me 21? What numbers do they both have in common? So after giving it some thought, I would determine that the only things that go into 7 are 1 times 7. So 1 and 7 are the only factors. 21 are lots. You got 1, 21, 3 and 7. So maybe not lots, but 4. Right? Well, what do they have in common? The greatest thing they have in common is 7. 7 is a factor of both 7 and 21. So as far as the GCF is concerned, I'm going to say 7 is the GCF as far as the coefficient. Okay. But when you're looking for the GCF, it's not just about the coefficient, the number in front of the variable. It's also the variables. If they have the same variables, the same letters, right? You have to consider that in your determination. So this one is x squared, meaning that there are 2 x's in the first term. This one is simply x. Only see one of them, right? So there's only 1 x here, 2 x's here. But as far as the most amount that they each have, look at each term. Each term has at least 1 x. So you have to say x as part of the GCF. 7x would be the GCF, the entire GCF. Okay. Now that you determine what the GCF is, That's step one. You have to then divide each term by said GCF. Okay, that's what goes inside the parentheses. Now, one of my clients this week was looking through this, and it seems like you had some practice with this, maybe in pre-algebra in years past. And so I'm going to go a little quicker because I feel like you need the other component, right? So 7x to the second divided by 7x, that's just going to leave you with 1x, excuse me. And then if you got a minus 21x, you divide that by 7x, that's just going to be a minus 3. The x's cancel out. You're done. You're absolutely finished. So this is the factored form of the polynomial 7x squared minus 21x. How do I know it's the factored form? Because if I were to multiply these two factors back by each other, times each other, it's going to equal the polynomial I originally had. That's what makes something a factor, right? So 7 times x is 7x squared. 7x times negative 3 is negative 21x. I know I factored this correctly, okay? So that's a little little reminder, a little refresher, midweek refresher as to how we factor if it's a GCF example. Now, one of the most popular, common, especially at the Algebra 1 level, types of polynomials that you'll be asked to factor, just being frank with you, one of the most common ones you're going to be asked to factor is what's called a trinomial, okay? A quadratic trinomial, to be more specific. So, for example, let's say you had a quadratic trinomial. The degree will be 2, and trinomial means that there are 3 terms. So a great example of that would look like this. I'm going to put this up on the screen so you can see it. This is a quadratic trinomial. Notice there's a degree of 2, so we call that quadratic. So this is kind of cross. I'm teaching, if you're doing classifying of polynomials, I'm kind of hinting at that, right? We're talked about how to name polynomials by degree and how many terms there are, right? So if the degree is 2, it's quadratic. If there's 1, 2, 3 terms, it's trinomial. So together, it's a quadratic trinomial. Okay. Specifically, when you're factoring those types, you have to do it a certain way. But first and foremost, you still need to look and see, does it have a GCF? Let's think about this. Is there anything in common between all 3 terms? Now, other than 1, you could always say 1 goes into everything, fine. But other than 1, we're not going to count that. There is not a GCF for this, but you still had to check for that. Now, the second question you need to ask yourself, and I'll put it in the chat as well, after you've determined, okay, there's no GCF, so what do I do? Can I still factor this? The second thing I would advise you to look for is to look for how many terms it has. I'll just say how many terms. Okay. So that'll be my second question. All right. Once I've done the GCF part, I've looked for it. Maybe there's not one. The next question you got to ask yourself is how many terms. Now, if there's specifically 3 terms, that's generally the type of process I'm about to go through here. Okay. So if you look at this, the golden rule is you want to look for 2 numbers that multiply to the outside number. Okay. So I'm going to say multiply. I'm going to put an M there for multiply. But you got to find the same numbers at the same time. They have to add to the middle coefficient. So in this case, we're looking for 2 numbers that multiply to 40, but if I added those exact same numbers, it would equal 14. So to do these types, you want to start off with 2 parentheses, unlike the other examples that only have 1 parentheses. Remember p squared, to get that, you just do p times p, all right? So we're just going to expand that into p times p. We're going to put that in the first 2 spots. But then we still got to figure out, okay, what numbers would do what I just said. So to give you a visual, we're looking for 2 numbers. If I multiplied those numbers, it would equal 40. But the same 2 numbers, if I were to add them, would equal 14. It's what multiplies to the outside and adds to the inside. That's how I typically would say it if you're in like a traditional algebra class with me, okay? I'm going to get rid of some of this extra chicken scratch so it doesn't look too confusing. What multiplies to 40 and adds to 14. So you got to think about it. There's a handful of different numbers that multiply to 40. For example, 8 times 5, I believe, is an option, right? That equals 40. But 8 plus 5 doesn't equal 14. So I got to go back to drawing board. What else gives me 40? You could say 20 times 2, right? That equals 40 if you multiply it. But if you add those, that's not 14. That's like 22, right? So you might have to go through it a few rounds. Eventually, hopefully, you settle on, wait a minute. Doesn't 10 times 4 also equal 40? So we put that in here. 10 times 4 equals 40. But guess what? If I took 10 and I added 4 instead of multiplying, it also equals 14. So in a sense, it checks both boxes. So I'm going to put a positive 10 plus 10 for positive 10. I'm going to put a plus 4 for positive 4. And guess what? I am finished. Okay. This is specifically how you factor a quadratic trinomial. It's different than the other kinds. Okay. But these would be considered the factors. How do I know I did it right, Chris? Well, once again, if you factor something, by definition, it means they can be multiplied to give you what you originally had. That's why if you take the number 10, for example, we would say the factors of 10 are 2 and 5 because 2 times 5 equals 10, right? Well, if I multiply these binomials by distribution, or some people call it FOIL, right? You're going to end up getting p squared plus 14p plus 40 there as well. Okay, so that's something to take into consideration. Now, one question that pops up and it can be confusing for some folks is when you have a combination. And I want to hit that real quickly before we move on. A great example of this, let me go ahead and put this on my board here so you can kind of see it. Let's say you had a trinomial that had a GCF, okay? So we're going to use 3n to the second power minus 9n plus 6 as that example. Just had to pull up my files here, so I had the examples ready to go. So this is one that has 1, 2, 3 terms. It's quadratic. The degree is 2. But remember, step 1, you still have to get used to doing this. See if there's a GCF. And after thinking about this, something that goes in all 3 terms, a common factor, I've determined that 3 is a GCF. It has one. That factor would be 3. So your job is, just like you normally would, tell me what the GCF is and then divide each term by the GCF. So that will leave me with n squared minus 3n plus 2, I think. Okay, I'm just trying to make sure I didn't do anything silly there. Always slow down. Sometimes if you go too quickly, you'll make a silly mistake. But yeah, I think I divided everything correctly. So we have done phase 1 of the factoring by getting rid of the GCF. It had one, we had to deal with it. But if you look inside the remaining parenthesis, you'll notice we could still continue to factor this because this is a quadratic trinomial. So the question becomes, just like the last one, what multiplies to the outside and adds to the inside? What multiplies to positive 2? 2 numbers, right? That if I added those same 2 numbers, I get a negative 3. Now, sometimes this can be confusing for certain students because negative numbers can be just, you're either a person who's good with negative numbers or you're not, in my experience. Some people have to spend a lot more time and effort and thought because they get confused in that area. But after giving it some thought, we know with trinomials, you need to do the variable and an n, split it up. But what multiplies to positive 2 and adds to negative 3, that's actually negative 1 times negative 2. Okay, a negative times a negative would still be a positive. Therefore, that multiplies to positive 2. But a negative 1 minus 2, or negative 1 plus a minus 2, you could say it that way, that would equal negative 3. And so that might take you a little more time to think through and do some trial and error because of, you got one number that's positive and one that's negative. But this is how you would tackle a question like this. So this week, if you're doing the factoring process, I don't think I have anybody who's kind of ahead of that. We're going to be looking at those 2 types, how to factor by GCF, how to factor a trinomial, and then how to do a combination where you have to do a GCF and then you have to take it a step further and do the trinomial piece. Now, that brings me to my next particular topic. If you're taking me and let's say you're on like week, I don't know what week that would be, probably like week 3 or 4, there's a good chance we're covering the classifying of polynomials section. So if you take a look, just to give you some examples, I wanted to just show you basically something that you're going to have on that first page of this week's assignment. So what you'll see on that first page, most of it is just a reminder of what we talked about, basically giving you a lot of the notes. We talked about how there's names for polynomials based on how many terms it has, but there's also names of polynomials based on the degree. So for example, you could have 3x to the second power, right? You could have another polynomial that's like 5x minus 8, and we're going to look at both of these. And then you could have another one that's, we'll do 4x squared minus 9x, let's see, minus 10. That's the other one, right? So let's take a look at this for a second. In fact, I think I want to change this to the third power. How about that? That'll be better. Okay, if you look at these 3 examples, these are all different polynomials. We talked about in class how a polynomial is anywhere from 1 to several terms that are joined together by either addition or subtraction. Just so happens my examples, once you get to the 2 term and the 3 term, they happen to be subtraction, but it could also be addition. Now, when it comes to classifying, I just want you to think of it like naming something, right? We talked about the example, I think it was, of dinosaurs. You can, there's all different types of dinosaurs, but there's but there's also specific types of dinosaurs. A T-Rex is not the same as a pterodactyl or a brontosaurus, right? But they're all dinosaurs. So just like that, these are all polynomials. But then there are certain specific names for the type of polynomial. So this one only has one term, okay? One term. If it's one term, we call that a monomial. Mono meaning one, monomial, nomial is kind of short for polynomial. So we call that a monomial. But then at the same time, there's only one term. It also has a degree, and the degree would be 3. You look at the power when I say degree. Well, the name for a degree of 3 is called a cubic. So we have one name based on the degree. The degree is 3. We call that a cubic, right? But it only has one term, and so we say mono for one, monomial. Got to practice saying that. But this would be considered a cubic monomial because the degree is 3, but there's only one term. If you look over here, this is where it can be a little bit confusing if you don't remember this. If it has a variable, look at this one. This one says 5x minus 8. They are not going to tell you that that is a degree of 1. They're going to assume that you know the exponent above the variable is technically to the first power. So when you have a degree of 1 like this, it won't look like that. They won't show you the 1. I'm just telling you what it is. They're not going to tell you that, but you're expected to know that. So this is a degree of 1, meaning we call that a linear. If the degree is 1, not how many terms, but if the degree is 1, that's called a linear polynomial. But notice there are 2 terms. Well, 2, think bicycle. Bi means 2, so we just call it a binomial for 2 terms. So those are the 2 names: linear, binomial. Degree is 1, linear, 2 terms, binomial. Lastly, this is the one that we were just looking at a second ago when we were looking at how to factor different types. Notice there are 3 terms and there's also a degree of 2. Remember, you go with the degree that matches the biggest term you have. So this is a degree of 2, that term. This is a degree of 1, that's 0, but this is the biggest one, so you go with that. Degree is 2, we call that a quadratic. I'm running out of room here, but since there are 3 terms, we call it a trinomial. So this is a quadratic trinomial, okay? So just look at that first page. If you're doing the assignments this week, it reviews the names based on the number of terms or the degree that you have, right? And so you can kind of be refreshed there about naming them. Okay, so moving right along, in addition to, see if I can find a good example here. I want to show you something. In addition to just classifying the polynomials, if you're taking my course, you were asked on this week's activity to do a process called adding or subtracting polynomials. And so that's a little bit different than just coming up with the names of them. So I do want to walk through one reminder example while we have the live today. And so that's going to look like this. Give me just a minute. Thank you for your patience. I'm just jotting it down real quickly, and then we're going to look at the screen together. Now, if you remember from class, we talked about when you're adding or subtracting, the same rules for both of those operations. When you're adding or subtracting, you want to look and match the variables and powers. That's how you know what to add together, okay? So like, for example, here you have 2 polynomials. They're both quadratic trinomials, but you'll notice there are 2 terms that each have an x squared, okay? You got 4x to the power of 2, or x squared, and you got 1x to the power of 2. Don't forget, if you just see x squared, that's considered 1x, okay? So that means only those 2 can be added to each other. You can't add them to the one that just has an x or the one that has no variable at all. These 2 have the same variable and the same power, so they're considered what are called like terms. You can add like terms together. So 4x squared plus 1x squared is simply 5x squared. You don't need to add the powers. You keep x squared. It's almost like identifying what term it is. And so you just leave it the same way. So now that we know that the x squareds go together, I would just look for any other terms that look alike, you know? So like right here, you got a minus 2x and a positive 3x, but they both have an x. And they're technically x to the first power because you don't see any exponent visible. So they're both x to the first power. They're alike. They're like terms. So they can go together. So that's -2 plus 3 for a total of positive 1. You could say 1x like this, but most of the time, like if you're taking a multiple choice test, they're not even going to put the 1 there. Okay, they're just going to say x. If there's 1x, you can simply just say x for short. And that's what's commonly going to be the case, okay? So you put the x's together, you put the x squareds together. Lastly, you put what are called the constants. Those have no variable. And so we got 8 plus a -2. If you add those up, that's going to be positive 6. And so you say plus 6. Guess what? We're done. Okay. You cannot add terms that don't have the same variable and the same power. They're not considered alike. It's like trying to add your apples with your oranges and your bananas at the grocery store. No, you get all the apples together and add them up. You get all the bananas together, add them up, right? And it kind of organizes it. But that's how you do an addition of what do you call it? Addition of polynomials. Okay. So we're making good progress. I've covered about 3 or 4 topics already. Okay. And so if you're also taking my course, there's a chance that you are kind of getting to that last phase, maybe the final 3 weeks. And that's when we try to sum up some of I don't know, just kind of hit you with random questions and see how you respond, if you have the skill set that you need to be able to problem solve and kind of think on your feet, right? And so you're doing a diagnostic this week to kind of see where we are, look at the lay of the land, see if I need to go back and reteach anything in particular. One of the things I wanted to cover was something called the property of exponents, right? And so when it comes to the property of exponents, you'll see this. I wanted to cover it because it's one of those things that I've seen over the years pop up on ACT style questions. And so I just want to touch on it really lightly, really quickly. And so if you see, or I should say when you see, I don't really think it's an if, I think it's a when. Let's say you have in parentheses something like 4x squared times y to the third. And then outside the parentheses, you see another 2. Okay. So I'm going to show you this. This is a very, I've seen this on many like practice ACT questions, but it's also an Algebra 2 and Algebra 1 standard, especially Algebra 2. Okay. There's several properties of exponents that you learn over the course of algebra. Okay. You'll learn that when you have an addition problem where you got a term plus another term, you don't really combine the powers. You just find what powers are the same and add them up. That's what we just did in the last problem. But if you have a situation where you're multiplying terms, or in this case, this looks like multiplication, but it's kind of deceptive. What this is really saying is 4x squared times y to the third to the power of 2. Okay. So this is technically being squared. All this inside is being squared, meaning that there are 2 rounds of this. If you wanted to, you could rewrite this as 4x squared times y to the third times another 4x squared times y to the third. That's what that really means. It means that there are 2 of whatever this is being multiplied together. So if you expand it this way, you could perform it and simply add the powers of the like variables, and you'd be able to see the answer. But based on this reality, this is called the power to a power property. You can kind of skip that step if you know this property. Anytime you have a base that has power, by the way, that is 4 to the first power, even though they don't say it. You simply take the power on the outside and multiply it by the powers on the inside. You can skip a step that way. It's called the power to a power property. So the first thing I would do here is I would say I would keep the base of 4, but 2 times 1 is 2. So don't forget that 2 out here applies to the 4 coefficient as well. That's going to become 4 squared. Then you multiply 2 times x squared, and you do 2 times 2. That's going to make that x to the power of 4. And then you multiply it by the y cubed, and 3 times 2 is 6. So this is the first set of moves I would do in a situation like this. Like I said, this is a nice, easy, if you can remember it, ACT question that you can get and make some progress with. Okay. And so you're not done here because while these are unknowns, we don't know what x is. We don't know what y is. So we can only stop here. X to the fourth, we got to stop there. It's a mystery. But because the coefficient's not a mystery, it's telling us it's 4. That's 4 squared. We can go ahead and figure that out. 4 squared, that really means 4 times 4. So that's 16. Now, so I just simplified a step further, and this is where I'm going to end up. Okay. This is where I'm going to end up. So you did pretty good on this. You know who I'm talking to, who's working through the diagnostic right now. But that is one I just wanted to make sure to go over a couple times because of the discussion we had. And the rest of it, we'll just kind of see what you remember, and we'll go from there. Okay. So the last thing I want to touch on while we end this, wrap it on up, is my Money Made Simple clients who are taking like our financial course. This is really good. If you're in my Algebra Made Simple course or Math Made Simple and you want to start giving them some connection between math, numbers, and money, you're going to be doing them a huge favor. And so my Money Made Simple client, you're kind of looking at, how do I word this? You're looking at this activity where we were talking about buying homes and buying houses, right? And so I felt like the discussion was pretty rich. But what I wanted to touch on is this week's assignment. It's page 3, and the assignment was called Buy It or Pass. In other words, is this a good decision, financial decision to make or not? And it gives you different scenarios to think through. So if you look at one of these, I'm going to talk about scenario 1. If you look at your assignment, I'll just read it for you. It says you find a house that's smaller than you want, but it's in a good neighborhood. So imagine this is you. Okay. Try to put yourself in this position. You find a house, it's a little smaller than you want, but it is in a good neighborhood. Okay. So take that into consideration. It's pretty old though, and there's a lot of repair work that needs to be done. Okay. So I'll tell you right now, I'm probably out because I'm not a fix it guy. Anyone who knows me knows I'm not the guy to go to do hand me, you're not good with a hammer. If you grew up that way, then that is different. But anyway, just this is the situation. There's a lot of repair work that needs to be done. It's kind of an old house. It's in a good neighborhood though. The house is $120,000. By the way, that's an incredible price at this day and age because of the way the market is. So this is a little bit dated question. The house is $120,000. You'll put 20% down. That's called a down payment. So you're going to find 20% of $120,000, which I believe is about $24,000. Okay, you got to pay that out of your own accounts. All right, and then the bank will fund the rest of it. They'll fund about what does that come to? About 96,000 of that amount, right? The bank is offering you a 7% interest rate for a 15-year mortgage, and you currently make $2,000 a month. It says with other monthly expenses averaging about $1,200. So maybe just, for utilities, for just some of the things you have to be spending just to live on, you got expenses of about $1,200. You only make $2,000 a month, right? And it says the repair work is going to cost you $10,000. Simple question. Are you going to buy this house or are you passing on it based on those circumstances? So what I want you to do, just to be extra clear this week, you need to go to Google, I would suggest, or go to, just go to Google. There's one website called bankrate.com and they have a mortgage calculator. That's basically what I'm saying. Go to Google, type in mortgage calculator, and pull up any mortgage calculator you want to. And I want you to put this information in. They should allow you to change the price of the loan that you want to do with the down payment. You can do 20%, type that in where it says down payment. You can put $120,000 for the price of the home. You can change the interest rate to 7%, right? Put in all that information. This is scenario 1 on page 3. And I want you to run it through the calculator, and let's see what that it's approximation about what that monthly payment would be. And then when you see that monthly payment, you're going to see, oh man, hopefully I can afford this, or I sure cannot afford this based on the fact that I make $2,000 a month, right? You want to do the numbers. You want to get an idea of what it really is going to cost you before you make a decision that puts you in a position where you have to pay that price for like 30 years or 20 years or 15 years, depending on how you set up the terms of your loan, right? So this is just meant to help you kind of think through what being an adult would be like and the common decisions that you have to go through all the time. Everybody has different situations, and based on your unique situation, one decision could be good for one person and a horrible decision for another, right? And so these are the kinds of things and the ways I want you to begin to think. So just reminding you of that, I want you to use some sort of mortgage calculator, and you can just Google it. In fact, if you want to make sure you're spelling it right, I think I'm spelling this right. It's like spelled mortgage. Okay. If you just type that right there, you'll get several options or websites that have them. A lot of like places that want you to finance through them will have a mortgage calculator as as an incentive to, whistles and bells to use them or whatever. But anyway, that's all it is. So anyway, this is this week's Q&A. If you are not able to catch it live, go ahead and watch the replay. It automatically records on YouTube, and you can send comments even late. So if you watch this 2 days later and you have a question, put a comment in there, and I should be able to get a notification and still respond to you. So that's a pretty cool feature. All right. I love you guys, and just keep studying hard and stay in there and hang in there and think, and you're going to get there. Okay. It's training you to think, to solve problems. That's what it's about. That's what opens up your future to more opportunities. I'll catch you on the next one.